Hello, everybody, and welcome to Silence Abounds Science at Home, where we will discover home lab magic. We will demonstrate experiments demonstrating scientific principles, concepts, and reactions in chemistry, biology, microbiology, microscopy, and molecular biology. Welcome to my channel. Hello, everybody, and welcome to another episode of Silence Abounds Science at Home, where we will discover home lab magic. In today's episode, we're going to look at what a colloid is. A colloid is a type of mixture where tiny particles of one substance are evenly dispersed throughout another substance, but not dissolved. These particles are small enough to stay suspended and not settle out quickly as in a suspension, but they are larger than the molecules in the true solution. A variety of colloid types exist, such as foams, emulsions, aerosols, gels, and sols. And we're going to be looking at a sol solution today and also a gel as an example of a colloid. A sol, S-O-L, is a type of colloid, a mixture in which very small particles are dispersed in a liquid medium but do not settle out upon standing. This is a typical example of a colloid. And the example we're going to use is iron 3 oxide. We're going to make iron 3 oxide sol. And this is a colloidal dispersion in which very fine particles of iron 3 oxide are dispersed in a liquid. It's a type of sol which is a colloid with solid particles dispersed in a liquid medium. When a dilute solution of iron chloride is added to hot water, iron 3 oxide particles, which is hydrated iron 3 oxide, form as a sol. And we're going to see that in today's experiment. For the two different experiments we're going to do, we're looking at the sol. You're going to need iron chloride, ferric chloride. You're going to need sodium chloride, aluminum sulfate. You're going to need calcium acetate, and we're going to need alcohol, ethanol. Now, I've already made the solutions ahead of time in the interest of time, and you don't really want to watch me making up different solutions. So I've made up a 30% iron chloride solution. You'll need to make a 0.5 mole per liter sodium chloride solution. You will need to make a 0.08 mole per liter aluminum sulfate. And then you need to make a saturated calcium acetate solution. What do we mean by a saturated solution? Basically, it's where you dissolve and you keep adding the chemical to your water until no more dissolves, because the water is so saturated with the compound that no more of that compound can dissolve. So it just remains in solid form in a solution. So I made my calcium acetate solution. So I've still got some solid forms of that in solution. So I know my solution is saturated. Okay, for the first part, let's now make our sol. Okay, first things first is we're going to prepare our iron 3 oxide sol. So I'm going to take 75, I need to heat 75 mils of water, and I want to heat it to boiling. Okay, 75. And I'm just going to put that on my hot plate, and that will boil nice and quickly, I hope. So I've got my ferric chloride solution here. And if I get a pipette, let's just take a look at the color of this solution. And it's, as you can tell, it's like a brown yellow solution, okay, to begin with. So that's ferric chloride, okay, and it's a clear solution. So what I'm going to do is I'm going to add 1 ml of 30% iron chloride to the boiling water, and I'm going to stir that. Let me get a stirrer if I have one. Okay, I'll just use a pipette, it's fine. Okay, so I'm just letting the water boil, and then I'm going to add 1 ml of iron chloride solution. Okay, my water is now boiling, so I'm going to add 1 ml of my iron chloride sol solution. And I'm going to get that a mix. And then I'm just going to let that cool down to proceed with the experiment. Okay, so the sol has cooled down now. So what I'm going to do is I'm going to pipette about 5 mLs of this sol into a test tube, like so. Okay, I'm going to put that aside. And then if you compare the color of the original solution, so remember the original solution was a yellowish brown. Now the solution is, the sol is now like a reddish brown color. So there's been a color change and indicating a new substance formed. The next thing I'm going to do is I'm going to add in as a control into my second test tube 5 mLs of sodium chloride. As you know, sodium chloride is a solution. It is not a colloid. Okay, 5 mLs of sodium chloride. And what I'm going to do now, I mean, they both look like solutions, okay? One's got a color to it, the other is clear, a clear solution, but not very remarkable to say. Which one is a colloid, which one's a solution, you won't be able to tell. One way to be able to tell is to shine a laser through the solution. And let's do that now. I'm going to turn off the lights and I'm going to shine a laser through the test tube and observe what happens. So I'm shining my laser through the sol solution, and you can clearly see the beam of the laser traveling through the solution. Okay, let's do it with the sodium chloride. as a control, and you do not see the beam going across the solution like you did with the SOL colloid. And this is a strong indicator, and the phenomena, a difference between the two solutions is because the SOL has very tiny, I don't know if you can pick it up on the camera, very tiny dispersed particles floating around the solution, dispersed throughout. And that's why the laser beam can be picked up and reflected. And this is called the tidal effect. And tidal effect is the scattering of light by particles in a colloid. It's a key phenomenon used to distinguish true solution from colloidal dispersions. Colloidal particles display Brownian movement. This phenomena consists of random particle movement in solution. It results from countless collisions between particles and the fast-moving molecules in the fluid. Even though suspended particles are much larger than the molecules in the fluid molecules hit them unevenly from all sides. And these unbalanced collisions result in irregular zigzag path and continuous motion, and therefore the particles never settle in solution. Okay, let's move on to the second part, the second demonstration of a colloid, and that is forming a gel using calcium acetate. You can prepare a gel using calcium acetate and ethanol, resulting in a semi-solid jelly-like substance. And this jelly-like substance is the basis of things like emergency fuel source, like canned heat. You can buy them like for camping trips or emergency supply. And calcium acetate forms a network structure with ethanol, causing the mixture to trap the liquid in a solid-like matrix, forming a gel. The gel is primarily physical and it's reversible with temperature or dilution. And we're going to demonstrate the property of how it can be used as a canned fuel, as an emergency fuel source. So let's prepare the gel. Move on to making the gel. There was one other demonstration I wanted to show you regarding the iron 3 oxide salt. So I've got my iron salt, and then I want to add 5 mL to the test tube. And I'm going to show you how we can precipitate out the salt. So put that in the test tube. Okay. And then I've got the sodium chloride. Again, I'm going to use as a control. And what I'm going to do is I'm going to add 5 drops of aluminum sulfate. Okay. 5 drops. Let me get my dropper out. And I'm going to add 5 drops. And we'll see what happens. Okay. And I'm going to do it, and I'm going to add it to each one. Then to the sodium chloride. Okay. That's that added. And what we do is, the reaction is kind of slow. So we'll come back to it periodically and observe any reaction occurring. So in the meantime, we can move on and make our gel. So I'm going to measure out 2 mLs of calcium acetate into a 50 ml beaker. So I got my 50 ml beaker here, and I'm going to pipette 2 mLs. I can use a measuring cylinder, but it's quicker. So 1 ml, 2. And oops, I've spilled that. You don't want to incorporate any of the solid suspended particles that are left because, remember, they are a saturated solution. Okay, so I've added 2 mLs of calcium acetate to the beaker. And what I'm going to do is I'm going to add 10 mLs of ethyl alcohol or ethanol. Okay, so I've got my alcohol here, and I'm going to measure 10 mLs. I've got a clean measuring cylinder. So I want to add 10 mLs. It's in a dropper bottle, so it's a little bit, doesn't come out easily. All right, so I've got 10 mLs of ethanol, and I'm going to add that to the beaker. Okay. And I'm not going to stir it. I'm just going to pour it all in once, and then we're going to see what happens. So it immediately has solidified. So it has solidified into a jelly-like gel, as you can see. There's still some residual alcohol on there. But what I'm going to do is I'm going to wait and let that alcohol evaporate off. And then I'm going to put the gel onto a watch glass and light it with a splint, demonstrating the canned heat capability of this gel. Let's take another look at the sol that we added aluminum sulfate to it. As you can see, it's starting to go cloudy. It's no longer a clear solution like this. So there's no reaction occurring in the sodium chloride tube, but you can see this is going cloudy. And this is because the sol is slowly precipitating out. And this is caused by the multiple charges in the aluminum sulfide. Okay, so now what I'm going to do is I'm going to put some of this gel onto my watch glass, and then I'm going to turn off the lights and apply a wooden splint flame to the gel. Okay. I've actually got a match instead of a splint. So now I'm going to apply the flame to the gel. So this is how camping lights work, and canned heat works. And this is a clear demonstration. What happens is the alcohol and the calcium acetate combine, forming this gel, and then the gel can be set alight and provide a heat source or candlelight atmosphere. And these gels can last quite some time, and that's why they are used as a form of fuel source. You can actually buy home fires using gel fuel, and this is demonstrating that principle. Well, I hope you enjoyed that video and demonstrating colloids, what a colloid is, and now understand and know what a colloid is. Please follow my channel, hit the subscribe button, doesn't cost anything, and it helps support me in my channel, making more and more of these videos demonstrating scientific principles and concepts and reactions through experiments. Please hit the like button and the share button. Send me a comment, and also feel free to email me. Send me your suggestions, questions, concerns, ways to improve my channel. Also, send me your photos and videos of you doing home lab experiments. Until next time, keep on experimenting. Goodbye, everybody.